We're going to go over activity number 2 here. So first problem, you are asked to evaluate piecewise function. You make the decision by looking at the conditions first and compare wherever your input belongs to. So for -2, it's clearly less than -1, so you only read the first row. Your function reads as 1 minus input. Input is -2. You could have stopped here, or you may decide to simplify it. Either one will be treated as acceptable final answer. So if your input is 1, which lies in the middle row, your function value is simply 3. F of pi is exactly the third group, so you can go with sine of pi, or you may know sine of pi is exactly 0. In order to plot the graph of this function, you're going to divide it into 3 different pieces, because clearly your function has been divided into 3 groups. So this is my first cutoff, which was -1. And the second piece is pi. Pi is somewhere over 3. So let's just put it at the right position somewhere here. So I have 3 different groups, and let's go ahead and plot it. When I'm looking at 1 minus x, when I'm less than -1, when my input is, let's see, -3, 1 minus -3 gives me an output of 4. So my function 1 minus x should go through -3, 4. When my input is -1, my function is 1 minus -1, hence 2. Don't forget you are not supposed to go across it, so I'm using the circle. And here we go. This is our straight line. And then we plot the second half. In the middle, my function reads as +3. So this is a straight line going through the height of 3. It's closed circle on the left because I do include it, but it's a circle on the right because it's excluded. The last piece is a sine function. Sine function is a periodic function. It's supposed to go like this, and then go like that, and that, and that. Of course, you are not supposed to keep this piece. Oops, sorry about that. You are not supposed to keep this piece, because your function only starts at the point of pi, and this is included. So that's the graph of my function. Don't forget, it should have been 3 pieces. You are supposed to mark the x and y intercept. You are supposed to put special attention to the boundary points. Use circle or dot to mark them clearly, and you can go over my expectations. I wrote those down here as well. So the next problem we said is we want to talk about the price of the cost of t-shirts. It's clearly I'm making the cut at 50 and 75. So that's 3 different categories. It is less than 50, it is greater than 50 but less than 75, and it is greater than 75. And when the first case, it's 15 times x. The second case is the first 50 or 15 per piece. The rest is 13.5 per piece, so I have x minus that. It's every number of pieces go beyond 50, and then the rest is 15 times 50 plus 13.5 times 75 minus 50, and then add up to 12.5 multiplied by x minus 75, because I'm having 3 different types of prices based on the number of t-shirts I purchase. So piecewise functions, based on the graph, we want to find the limit and function values. So when I'm reading f of -4, I'm reading here, I realize I don't go across anything. This only piece is a full circle, so my function value does not really exist. And when I talk about limits, when I'm approaching to it from either left or right, I realize I'm approaching to the same point, which is height of 2. So my left limit is 2, my right limit is 2, because they match, my limit is 2. Along the same line of thinking, if I were to approach to the point of 1, if I go across it, I notice that I'm actually going through this point, so I have a function value of 4 here. When I'm approaching to from the left, hence left limit, I'm going into 4. When I'm going toward from the right, so my right limit is -2, because left, right give me contradicting information, so my limit doesn't really exist. So what I end up with is 4, -2, and does not exist. For the next case, I'm looking for what's going on when my input is 6. My function value is this solid dot here, hence 2 But when I'm approaching to that point, I realize I'm approaching to the same point both from left and right. So my limit is the height, which is 5. So what I end up with function value being 2, my left-right limits are 5, so my limit actually is simply 5. Well, the connection between two one-sided, so the left limit and right limit, compared to the limit, what you have is that the limit exists if and only if the left limit and the right limit, they are the same thing. So the left limit equals the right limit. That's the only possibility. If you have a limit, those two one-side limit must be equal to each other. The next thing is, if your function has a limit, does that mean your function value at the given point match with that? Well, the answer is no, because if you look at the case, f of 4 does not exist, which is not the same as the limit x approaches negative 4 f of x, which because it's 2. So that's quite clear. You cannot always assume your function value would match with the limit of your function at the same point. So the next problem we have here is about the properties of functions. I do want to clarify it's a common habit that everything you squeeze behind the limit is going to be treated as one term. So for clarification purpose, this is actually what I meant, but that's how I'm going to type out my equations in my test as well. So the first piece, hopefully it's trivial. You can move the 3 out like this first property. So I end up with x approaches 2 f of x. Namely, it's 3 times negative 3. You may simplify it if you like, right? And the next thing we have is the limit as x approaches 2 f of x, add to the limit x approaches 2 of g of x. So that's two separate limits. The first one is negative 3. The second one is limit x approaches 2, 3 times x minus 6. You could have calculated on the side if you want, because we're going to use it repeatedly. So this is a linear function. If you want to find the limit of a linear function, it's just a matter of substitution. So what I end up with is 0. So this is 0. Your final answer in this particular case is negative 3 plus 0, which is negative 3. Next problem is mathematically equivalent to twice of limit x approaches 2 f of x minus limit x approaches 2 of g of x. Hence, it's twice times negative 3 minus 0, which is negative 6. The next problem is limit x approaches to 2 of g divided limit x approaches to 2 f of x. So you end up with 0 divided by negative 3, which is 0. Last problem tells you are going to find the limit of g, x divided by twice limit x approaches to f of x. You can have it squared and then add to the limit of 3. Well, this is like 0 over twice of negative 3 squared, right? And then plus, okay, think about it. This is a constant function. No matter where I'm going, I'm staying at the same height. So the second half always have 3, so you have 0 plus 3. So you end up with a final answer of 3. So let's box my final answer so it's easier for everyone to read. Like we said, it doesn't really matter whether you do the limit calculation first or you do the limit calculation in the end. It has such nice property that you definitely want to take advantage of. So this is the last problem.